Imagine stepping onto a train, sitting down comfortably, and watching the world blur into streaks of light as you accelerate to 600 kilometers per hour, faster than a commercial airplane during takeoff. Yet you never feel the shaking, the rattling, or the pressure of wheels grinding along metal tracks, because this train doesn't touch the ground at all. This is China's 600 kilometers per hour Maglev, the fastest ground vehicle ever built. A machine that floats, flies, and glides using forces you can't see, and engineering secrets they rarely talk about. But behind this futuristic masterpiece lies a complex story, a race for global dominance, massive technological leaps, and controversies that could determine who controls the future of transportation. China didn't just decide to build the fastest train in the world, it decided to redefine what ground transportation could be. In the early 2000s, China looked at Germany and Japan, who were pioneers in Maglev technology. But instead of buying their trains forever, China wanted something bigger. Maglev technology with its own design, its own patents, and its own global export power. A decade of experiments led to the birth of the 600 kilometers per hour prototype. Soft launching in 2021, the train instantly captured worldwide attention. It wasn't just a train, it was a statement. A symbol that China was stepping into a new era of engineering supremacy, one that could potentially dominate high-speed rail markets for the next half-century. What makes this train revolutionary is that it eliminates friction entirely. Instead of wheels, it uses two key systems. First, the electromagnetic levitation coils, which lift the train up to a few centimeters above the track. No physical contact means no wear and nearly no noise. Second, the linear motor propulsion, a system that creates a rapidly moving magnetic field along the guideway, pulling the train forward like it's being yanked by invisible force. Inside the train, passengers feel none of the violent shaking that wheel-based trains experience at high speeds. Everything becomes silent, almost unnervingly smooth. The only sensation is acceleration, and after that, just quiet, effortless motion. But what they don't show is how incredibly difficult this is to maintain. One misalignment in the track, one faulty coil, one unstable magnetic pulse, and the system collapses. The engineering behind this smooth ride is far more intense and complex than the glossy demos reveal. Reaching 600 kilometers per hour isn't just about speed, it's about defeating physics. At these velocities, even air becomes a force strong enough to tear metal. Engineers had to redesign the nose for perfect aerodynamics and develop lightweight materials capable of resisting extreme pressure. Cooling systems had to be re-engineered because the train generates massive heat along the magnetic path. Safety buffers had to be reinvented. At 600 kilometers per hour, stopping is not just difficult, it's nearly impossible without kilometers of emergency track. And then there's the biggest limitation, power consumption. This train requires an enormous amount of electricity to hover and move. While Maglev eliminates wheel friction, it replaces it with massive magnetic energy demands, something most countries simply can't support without upgrading their entire power infrastructure. This is why many nations admire Maglev technology, but hesitate to adopt it. China's Maglev isn't happening in isolation. Japan has been developing its own ultra-fast Maglev, the Chuo Shinkansen, capable of reaching 500+ kilometers per hour. For decades, Japan held the crown in Maglev technology, but China's rapid progress changed everything. Suddenly, the world saw two Asian giants competing for the title of fastest train on Earth. Japan's system uses superconducting magnets, requiring cryogenic cooling, while China focuses on room temperature electromagnetic technology, which is cheaper and easier to roll out at scale. Behind the scenes, it's more than engineering, it's influence. Whichever country perfects Maglev first could redefine global infrastructure and secure multi-billion-dollar export deals. And China wants to become the world's high-speed rail supplier. Despite the hype, China has not yet deployed the 600 kilometers per hour Maglev on a major route. The biggest challenge is cost. Building Maglev lines requires entirely new tracks. Normal high-speed rail tracks won't work. The guideway is expensive, the power needs are enormous, and maintenance requires highly specialized teams. Currently, China is testing the system on limited tracks in Qingdao and expanding test routes. The first realistic deployment might be a Maglev corridor between Shanghai and Hangzhou, cutting a 2-hour trip to just 15 minutes. But even that requires billions in investment. So while the train exists, the question remains, when will the real routes happen, and how much will China gamble on this tech? Inside China, not everyone supports the Maglev expansion. Economists warn that the cost may outweigh the benefits. Provincial governments fear massive debt. Some critics argue Maglev tech is more about prestige than practicality. There are also political tensions. As China pushes Maglev development, Japan views it as competition for future global rail contracts. Meanwhile, European rail experts question whether the operational costs will skyrocket over time. Environmental concerns also enter the conversation. Maglev guideways require huge land usage, and strong magnetic fields, while not harmful, still spark public debate. And building new Maglev lines often means clearing land, displacing communities, and restructuring entire regions. In short, the controversies behind the scenes are just as dramatic as the technology itself. Despite the challenges, the potential impact is enormous. Could turn massive countries into small worlds. A fully developed 600 kilometers per hour Maglev network, a trip that takes 3 hours by bullet train, could take 40 minutes. Major economic zones could merge. Cities could expand outward without traffic concerns. Entire populations could work in one city and live in another without stress. And for the world, a successful rollout could trigger a new era. The same way the jet age changed travel in the 1960s, Maglev could become the next global standard, replacing conventional high-speed rail, just as high-speed rail once replaced slow diesel trains. China's 600 kilometers per hour Maglev isn't just a machine. It's a blueprint for the next century of mobility. Whether the world is ready for this future or not, one thing is clear. The 600 kilometers per hour Maglev proves that technology has crossed a line we once thought impossible. It's a train that doesn't touch the ground, a machine that challenges physics, a symbol of national ambition, a promise and a warning that the next transportation revolution won't happen on wheels. But the real question remains, will this floating giant reshape the world, or remain a brilliant experiment waiting for the moment humanity catches up? Either way, the future of travel is no longer rolling forward, it's levitating.